A while ago, my GP30 arrived, but I didn't find the time to make the modifications I wanted to do. Now I did, and here's the story. I selected this specific road number because this engine wasn't rebuilt until 1989. While researching the prototype engine, I noticed that it had the headlights on the nose instead of in between the number boards. Atlas included an unlit headlight in the model. Judging from the pictures of other models I have seen, it seems like they only did this with the BN models. So I wanted to move the lit headlight to the nose of my copy of the model and close up the headlight detail between the number boards where the prototype had the mast light before it was removed. I also wanted to put as many keep-alive capacitors into the engine as I could manage, move the horn to its prototypical position, and add a beacon. The decoder board comes with plenty of LEDs assigned to function outputs. However, they're already installed on the decoder board and not particularly useful in those positions. Since I wanted to keep the number boards illuminated and also wanted to add a beacon to the roof of the cab, I needed 3 LEDs in total. After inspecting the light board, I decided to use the pads of the 2 LEDs on top of the light board and of 1 underneath the light board. I also didn't want to remove the light board because I still don't know the exact purpose of the foam on top of the frame. This would make things a bit difficult later, but was still reasonably manageable. Adding a keep-alive to these boards is a bit tricky, since there are no designated pads for any of the required connections. While researching for this project, I found a detailed write-up of the decoder board design over on the Railwire forums. I've put a link to it in the description. Soldering the keep-alive to the board requires soldering the positive lead to a small SMD component. The other contact can be attached to one of 3 capacitors, which have much larger solder pads to work with. I used to build my own keep-alive from tantalum capacitors and Zener diodes, but since then manufacturers have come up with solutions that work well in N-scale engines. I decided to use a Döhler & Haas D&H SP16A keep-alive board. It comes with a 470 microfarad capacitor from the factory and solder pads for additional capacitors. It also comes with some extra components that make it possible to load sound files into the decoder and program the decoder even with the keep-alive attached. And even more important than any of that, it fits nicely underneath the decoder board. I decided that soldering the positive lead to the tiny SMD voltage regulator had the highest chance of breaking things, so I wanted to get that out of the way first. I clamped the voltage regulator down with locking tweezers to reduce the risk of accidentally moving the component off its solder pads. The tweezers also act as a heatsink, which should help avoid damage as well. Then I heated up the pad and added a good amount of fresh solder to it. After that, I soldered the wire to the pad. I had only removed the insulation from the very end of the wire, so it wouldn't touch any nearby contacts by accident later. When soldering the negative lead to one of the capacitors, I followed the same steps. The larger size of the components made this step a lot easier. The keep-alive board doesn't have any markings for the solder pads, so I marked the pads myself to avoid any confusion later. I positioned the board roughly where I wanted it to sit in the engine and cut the wires to the appropriate length, allowing some slack for wire routing later. Soldering the wire to the contact pads while holding the keep-alive board in place is a bit finicky. I used locking tweezers to hold the board in place while keeping the tweezers from moving with the palm of my hand. Even though the components on the keep-alive boards should keep any electrical contacts from accidentally touching the frame, I put Kapton tape on top of the frame to be sure. Since I wanted to use wired SMD LEDs to light the number boards and the headlights, the SMD LEDs on the board had to be removed. I found grabbing the LEDs with tweezers and gently pulling them off the board while heating up the pads worked well. Then I prepared the pads by adding fresh solder to make it easier to solder to them later. After testing the drive to make sure that the decoder board had survived my modifications, it was time to prepare the shell. The horn was in the wrong position for the prototype and also in the way of the planned beacon, so I removed that first. In order to remove the light conductor assembly for the number boards and front light, I removed the cap first. Then I pushed the light conductor out with a toothpick. Doing so helps avoid damaging the print on the number boards. After that, it was time to remove the old headlight detail. I gently filed it off with a small file and then used Tamiya plastic putty to close up the holes for the headlights and the horn. After cleaning up the inside with a toothpick and filing the putty flush with the front, I glued a headlight cover detail part from BLMA in place with CA glue. I never liked the light bleed caused by the windshields being part of the light conductor on this engine, so I used the opportunity to make this a separate part. Since I didn't plan to preserve the headlight between the number boards, I didn't need to worry about breaking the old light conductor knobs. I have done the same modification on other Atlas engines that have the windshield as part of the light conductor, where I had to preserve the headlights, however. So it is possible to do, and I think it's well worth the effort. Then I cut off the back side of the light conductor with a small saw to make room for additional keep-alive capacitors. After cleaning up the edge, I filed a small notch into the number board light conductor to make room for the LED. It's easy to break the light conductor at this step, so it's best to avoid much pressure while filing. The work on the light conductor didn't leave the number board print unharmed, so I touched up the edges with a black Sharpie. Now it was time to glue the LEDs into place. I used the same type of pre-wired 0805 warm white S&D LEDs for both the headlight and the number boards and glued them into place with CA glue. The gluing process can be a bit tricky because all the parts are small and it's a lot easier to glue the parts to the tweezers than it is to glue them to the things you actually want to glue them to. I usually hold the LEDs with locking tweezers with some kind of makeshift padding and carefully maneuver them into place. Once they rest against the part they're supposed to be glued to, I carefully apply the CA glue with a toothpick and don't touch any of the parts for half an hour to make sure that the glue is fully set. CA glue cures by reacting with moisture and can take a surprisingly long time to cure when exposed to dry air. After that, I like to apply another drop of CA glue for extra strength. I don't trust the enameled wire of the LEDs to fully insulate against the frame forever, so I applied Kapton tape to the wire leading to the LED for the nose headlight for extra insulation and also to keep the wire from moving unintentionally. After reinstalling the number boards, I painted the number board light conductor and the nose headlight from the inside with black paint to stop any light leaks. Then I glued the windshield into place with canopy glue and painted the light conductors again with black paint. This time, I also tried to get the paint between the number board light conductor and the windshield to make sure that the windshield no longer lights up. After carefully reassembling the shell, it was time to solder the LEDs to their pads on the decoder board. The LEDs I used had a red wire for the positive lead, and the corresponding pads on the decoder board are on the right hand or engineer's side of the engine. When all wires were soldered into place, I secured the wiring against the cap roof with another piece of Kapton tape. The tape doesn't like to stick to the plastic of the shell very well. Applying a bit of paint or CA glue to the area where the tape is supposed to go helps quite a bit, however. After securing the enameled wire to the decoder board with tape, it was time to prepare the additional capacitors for the keep-alive. In this model, there is additional space for a 470 microfarad capacitor in the rear underneath the decoder board, and the cab has space for a 470 microfarad plus a 220 microfarad capacitor soldered together. All the capacitors come in 2917 type packages. The 220 microfarad capacitors are 3.1 mm tall, while the 470 microfarad type is slightly taller at 4 mm. The keep-alive board works with 16-volt capacitors. I have put links to the parts I used in the description. The Tentel S&D capacitors have a marking for the positive contact on the housing. And it's important that all the additional capacitors are connected to the Keep Alive board with the correct polarity. The capacitor already on the board has the same type of marking, so all the marked sides of all the capacitors need to be wired together. When all the additional capacitors and their wires were secured, it was time to put the shell back on the frame to see if everything would actually fit the way I had planned. And with a satisfying click, the shell snapped into place. The horn was placed by the rear radiator fans on the prototype. The horn that came with the model wasn't tall enough for that, so I used a brass part from Atlas, drilled a hole into the shell at the spot where I wanted the horn to go, and secured it with CA glue. When the glue had cured, it was time to put the model on the layout for a quick test. It was only when I reviewed footage from the start of the video that I realized how dim the headlight was before the modifications. That's all for today. If you have any questions, let me know in the comments. See you next time.